Hello there, and welcome to the calm space of LUMIVERSENL. Wherever you are tonight, under city lights or beneath a quiet sky, allow yourself a moment of stillness. Let the noise of the world fade away and let your thoughts drift like soft particles of starlight. Breathe slowly and imagine floating through the vast ocean of space. You pass hidden planets, silent and distant. You pass suns that burn for billions of years. You pass galaxies older than memory itself. Tonight we begin a gentle journey through the most relaxing facts about the universe. Facts that help the mind unwind while teaching the heart to wonder. Because every truth written in the sky is a lullaby made of light. There are more stars in the universe than there are grains of sand on all the beaches of Earth. If you have ever stood by the sea and watched the sand slip through your fingers, imagine that multiplied beyond imagination. Each grain of sand could be a world, and yet the stars far outnumber them. Every star is a glowing sphere of plasma shining across impossible distances. Its light travels for millions of years before touching your eyes. Some stars are smaller than our sun, others hundreds of times larger. Many are surrounded by their own planets, moving in endless silence. Together they form a vast ocean of light and energy that stretches farther than thought can reach. The sheer scale humbles us. It reminds us that each star you see is not just a distant point, but a sun that might warm another world. Perhaps with oceans and clouds, perhaps with dreams waiting to be imagined. In this infinite sea, we are made of the same dust that creates the stars. Our thoughts, our breath, and the quiet between heartbeats follow the same rhythm that echoes through galaxies. And as you rest, let that rhythm settle gently within you. You are not apart from the universe. You are part of it, a small spark of awareness carried among the stars, moving within the same light that fills infinity. If this peaceful exploration brings you calm, stay with us and continue the journey. Subscribe to explore more of the universe in stillness and sleep. The observable universe stretches across 93 billion light-years. Every direction you look, the light that reaches us has traveled for almost 14 billion years since the first moment of creation. This boundary, called the cosmic horizon, is not a wall or an edge. It is simply the farthest distance from which light has had enough time to arrive. Beyond it, space continues without end, holding galaxies we will never see and mysteries we can only imagine. The light we observe today began its journey long before Earth existed. When you look at a distant galaxy, you are seeing it not as it is now, but as it was billions of years ago. You are witnessing ancient history written in light, a story told by photons that cross time and emptiness to reach you. Each point in the night sky is both a window to the past and a reflection of how far we have come. The universe is still expanding. Galaxies are carried away from one another as space itself stretches. Imagine dots on the surface of a balloon as it inflates. The dots do not move across the surface. It is the surface itself that expands, carrying the dots apart. In the same way, galaxies drift apart not because they are flying through space, but because space itself is growing between them. This expansion defines the rhythm of the cosmos, a slow and silent movement that has never stopped. Long ago, many believed the universe would slow down over time. But scientists discovered that the opposite is true. The expansion is speeding up, driven by something mysterious called dark energy. It acts like a pressure that pushes galaxies away faster and faster. No one knows exactly what dark energy is, but it now fills most of the universe, shaping its future in ways we can barely understand. The stars, the galaxies, even the atoms in your body all drift apart through this expanding sea. And yet, within that vast motion, everything remains connected by invisible threads of gravity and light. You are part of this expansion too, carried gently through space as the universe grows around you. There is no center and no edge, only motion without boundary and time without end. So as you breathe, imagine yourself floating quietly in that great unfolding. The galaxies move, the stars burn, and the fabric of space stretches in silence. Every second, the universe becomes a little larger, a little older, a little farther beyond our reach. And still, within its immensity, there is peace. Because even in infinite expansion, everything remains part of one connected whole. If this calm knowledge brings stillness to your mind, stay with us as we continue to drift through space and time. There is more to see, more to feel, and more to understand in the quiet rhythm of the cosmos. The story of our universe begins with an event more profound than any explosion. It was not a blast that tore through space, but the moment when space and time themselves came into existence. We call it the Big Bang, though that name does not capture its true nature. There was no place for the explosion to occur, and no time for it to unfold. Instead, everything, matter, energy, and the laws that guide them emerged from a single state of unimaginable density and heat. In the first fractions of a second, the universe expanded faster than light in a process known as cosmic inflation. During that instant, the fabric of space stretched beyond measure, smoothing out irregularities and scattering energy across the newborn cosmos. This rapid growth set the foundation for everything that would follow. Tiny fluctuations in energy became the seeds from which galaxies, stars, and planets would eventually form. From absolute simplicity arose the complexity that now fills the night sky. As the universe expanded, it also cooled. Within minutes, subatomic particles joined to form the first atoms, mostly hydrogen and helium. These light elements filled the cosmos, drifting through the growing void. There were no stars yet, no light to see, only darkness and silence stretching in every direction. For hundreds of millions of years, the universe existed as a vast sea of invisible gas. But that darkness was not empty. It was potential, waiting to ignite. Eventually, gravity began to pull matter together. Tiny ripples of density grew heavier over time, forming clouds that compressed under their own weight. When these clouds became dense enough, something extraordinary happened. The first stars were born. These ancient suns burned far hotter and lived far shorter lives than the stars we see today. They illuminated the universe for the first time, ending the long cosmic night. Their light filled the void, transforming the silent darkness into a luminous sea. Even now, traces of that beginning remain all around us. The ancient glow known as the cosmic microwave background still fills every corner of space. It is the faint afterglow of the Big Bang, radiation that has traveled for nearly 14 billion years. Though invisible to human eyes, it surrounds us in every direction, a silent reminder of our origin. When scientists study this ancient light, they see patterns so delicate that they reveal the earliest moments of cosmic history. Small temperature variations in that glow map the first structures of the universe, showing where matter would later gather to form galaxies. This radiation is a cosmic photograph, taken when the universe was only 380,000 years old. Before that moment, space was filled with charged particles and photons locked together, scattering endlessly. But as the universe cooled, the photons broke free, beginning their long journey through time and distance. Those same photons now reach us as a whisper of warmth, evidence that everything we know began in that single, glowing instant. Imagine that faint light still streaming through space, touching worlds, dust clouds, and your own skin as you rest beneath the stars. It connects you to the dawn of time, linking every atom in your body to that first spark of creation. for the hydrogen that flows through your veins was born in those first moments. The same elements that fill your lungs once danced in the fire of the early universe. You are a continuation of that beginning, a reflection of the cosmos itself. So when you look at the night sky, remember that it is not a distant place but a story still unfolding. Every star, every particle, every breath is part of the same origin. The Big Bang was not an event that happened long ago and ended. It is still happening, still expanding, still carrying us outward into the unknown. And within that endless motion, there is calm, the quiet heartbeat of creation that continues in every direction, even now. If this journey through the beginning of time stirs your curiosity or helps you rest, take a moment to stay connected. Let your mind drift with us as we continue this path through light and silence. The next chapter awaits where invisible matter shapes the very structure of the universe. Invisible matter we cannot see holds the universe together. It neither shines nor absorbs light, yet it outweighs all the stars, planets, and gas that fill the heavens. This mysterious substance is called dark matter, and it makes up about 85% of all matter in existence. Without it, galaxies could not stay bound. Their stars would spin away into the void, scattering across space. Dark matter acts as an unseen framework, a silent web of gravity that shapes everything we observe. We know it is there because of how it pulls. Astronomers watch the motion of stars and galaxies and see them move faster than visible matter alone could explain. Something unseen provides the extra gravity to hold them together. That hidden structure forms a vast cosmic skeleton, connecting galaxies like threads in a web stretching across hundreds of millions of light years. This invisible scaffolding guides the growth of the universe, determining where stars and galaxies will form and how they will evolve over time. If we could see dark matter, the night sky would appear as an intricate network of glowing filaments. Galaxies would lie like jewels along these threads, while vast empty spaces known as cosmic voids would separate them. This pattern is called the cosmic web, and it defines the universe on its grandest scale. Every cluster, every filament, and every void is shaped by gravity's delicate balance between dark matter and ordinary matter. Even though we cannot see it, we live within this invisible structure every moment. Scientists still do not know what dark matter truly is. It might be made of unknown particles that barely interact with ordinary matter. It could be a manifestation of forces we have not yet discovered, or perhaps a hint that our understanding of gravity itself is incomplete. Whatever its nature, dark matter remains one of the deepest mysteries in modern physics. Its existence tells us that most of the universe lies beyond the reach of our senses. Yet the story does not end there. Something even more mysterious pushes the universe to expand faster and faster. This strange force is known as dark energy, and it fills the empty space between galaxies. Unlike gravity, which pulls matter together, dark energy drives everything apart. It acts like a cosmic pressure that accelerates expansion, stretching the fabric of space itself. Dark energy now accounts for nearly 70% of the total energy of the universe, making it the dominant force shaping our cosmic future. Astronomers once believed that the universe's expansion would slow down over time, gradually halting under the pull of gravity. But when they studied distant supernovae, they found that those explosions were dimmer than expected, meaning the galaxies hosting them were farther away. The only explanation was that the expansion of space had been speeding up. That revelation changed everything. It meant that the universe is not just growing, it is accelerating. And something unseen, something deeply fundamental, is responsible. We still do not know if dark energy will continue forever or if it will one day change its nature. If it keeps increasing, Galaxies will drift so far apart that their light will never reach one another. The stars will fade, the night sky will grow dark, and the universe will become a cold, silent sea. But if dark energy weakens or reverses, gravity could eventually pull everything back together, ending the cosmos in a slow collapse. Some scientists call that possibility the Big Crunch. Others imagine a balance where expansion and gravity reach a quiet harmony that lasts for eternity. Between these two invisible forces, dark matter that binds and dark energy that separates, lies the delicate tension that shapes reality. We exist within that balance, on a small world orbiting an ordinary star, surrounded by mysteries larger than imagination. Every atom in your body moves in rhythm with these cosmic forces. You are connected to the same gravity that forms galaxies and to the same expansion that carries them away. The space between your atoms expands ever so slightly with the rest of the universe. Even as you sit still, you are part of this vast motion. So when you close your eyes tonight, picture the hidden web that holds the stars together. Imagine threads of gravity stretching beyond sight, linking galaxies, clusters, and worlds. Through those invisible filaments, light travels, matter gathers, and creation continues its endless dance. You are not separate from it. You are woven into that same cosmic fabric. The darkness that surrounds you is not empty. It is full of connection, full of quiet power, and full of stories still unfolding across the stars. If this thought brings calm, take a deep breath and let it settle. Because what we call darkness is only another form of light, one we have yet to understand. Stay with us as we continue to explore this hidden structure, the delicate web that holds the universe together. The galaxies that fill the universe are not scattered randomly. They are arranged in vast networks, connected by invisible bridges of gravity and dark matter. Astronomers call this structure the cosmic web, and it stretches across the entire universe like a delicate net of light and shadow. Within it, galaxies cluster along thin filaments, while enormous empty regions known as voids span the space between them. From a distance, the universe looks less like chaos and more like a living structure, an intricate design drawn in stars. Each filament in the cosmic web can stretch for hundreds of millions of light years. These immense threads form the highways of the universe, guiding the movement of galaxies and gas. Gravity flows along them like currents in an ocean, pulling matter into great intersections called galaxy clusters. In these clusters, thousands of galaxies gather together, orbiting one another in a slow, grand dance that has lasted for billions of years. The cosmic web is not static. It evolves, reshaping itself as galaxies collide, merge, and drift. Every strand changes over cosmic time, yet the underlying rhythm remains the same. Expansion, connection, balance. This vast structure could not exist without dark matter. Although we cannot see it, dark matter's gravity provides the scaffolding upon which everything else is built. Galaxies form where dark matter is densest, clustering along its filaments like dew on a spider's web. Where there is little dark matter, there are few galaxies, and so the voids remain empty and silent. Through this hidden balance, the universe maintains its architecture, an elegant equilibrium between seen and unseen. In the midst of this web lies our home, the Milky Way galaxy. It is a vast spiral of stars, gas, and dust, spinning through space at more than 500,000 miles per hour. Our solar system is carried on this great rotation, circling the center of the galaxy once every 250 million years. As we travel, we move through arms of stars and clouds of gas, where new suns are born. Despite the incredible speed, The distances between stars are so immense that collisions are almost impossible. We move through emptiness, surrounded by silence, held in place by the invisible pull of gravity. The Milky Way itself is part of something even larger. It belongs to a small cluster of galaxies known as the Local Group, which includes the Andromeda Galaxy and dozens of smaller companions. Together, these galaxies are bound by gravity, slowly orbiting one another as they drift through space. In about 4 billion years, the Milky Way and Andromeda will collide. But it will not be a violent impact as we imagine. Instead, it will be a graceful merging that unfolds over billions of years, as stars weave together and reshape their orbits. From that union, a new galaxy will emerge, a vast, elliptical form glowing softly in the dark. Such collisions happen often across the universe. Galaxies are not isolated islands. They are participants in an endless cycle of meeting and merging. When they approach one another, their gravity stirs clouds of gas, triggering bursts of star formation. Stars rarely collide directly, but the movement of matter and energy transforms everything. In this way, galaxies evolve, growing larger and more complex with each interaction. The universe is not a static collection of stars, but a living system, constantly reshaping itself through gravity's patient hand. Even the space between galaxies is not truly empty. It is filled with thin gas, dust, and invisible streams of energy that connect everything together. These faint currents carry the memory of past collisions and the seeds of future ones. Each wave of motion, each gravitational pull, writes another line in the ongoing story of the cosmos. And through it all, light travels endlessly, illuminating the delicate design of creation. When you look at the night sky, you are seeing only a small part of this grand structure. Each star above you is a fragment of a larger pattern, one that stretches far beyond imagination. It is humbling to know that our galaxy, vast as it is just one thread in an infinite tapestry. We are travelers within it, carried by gravity through the same network that has existed for billions of years. Every light you see, every darkness between, is part of a single, connected whole. If this thought brings quiet wonder, take a breath and let it rest in your mind. The web that holds the stars also holds you. Invisible forces guide everything that exists, galaxies, worlds, and the fragile consciousness that observes them. As we drift through this cosmic structure, remember that you are not lost in its immensity. You are part of it, moving gently through the luminous fabric of the universe. The Milky Way, though vast beyond comprehension, is only one of hundreds of billions of galaxies woven into the cosmic web. Each galaxy spins within its own invisible halo of dark matter, held together by forces that reach far beyond what we can see. Within these spirals and clusters, stars live, die, and are born again, continuing the universe's unending rhythm of creation and transformation. It is a cycle of light and shadow, of birth and decay, written across billions of years. Our galaxy itself is in constant motion, gliding through space with quiet grace. We are carried within its spiral arms, surrounded by clouds of dust and glowing nebulae where new stars emerge. Every atom around you once belonged to an older generation of suns. When those ancient stars reached the end of their lives, they exploded in brilliant supernovae, scattering the heavy elements that now make up your body. Iron in your blood, calcium in your bones, carbon in your breath, all were forged in stellar fire. You are, in the most literal sense, the universe becoming aware of itself. As galaxies move through the web of gravity, they sometimes collide in slow, majestic dances that last billions of years. When two galaxies draw near, their gravitational pull begins to distort their shapes. Tidal forces stretch and twist them until their stars form long arcs of light. Gas clouds crash together, compressing and triggering bursts of star formation. These moments of cosmic turbulence create some of the most beautiful structures in the sky. Luminous bridges, glowing tails, and brilliant cores where new suns ignite. Yet, despite the immense forces at play, individual stars rarely collide. The distances between them are simply too vast. It is gravity, not chaos, that orchestrates the dance. Our own Milky Way is part of this endless ballet. In about 4 billion years, it will meet the Andromeda Galaxy in a slow embrace. The two will merge, forming a single, larger galaxy. From afar, it will appear as a serene blending of light, a soft collision that reshapes the structure of both. To any life that may exist within, the sky will change beyond recognition. New constellations will form. The night will glow with billions of unfamiliar suns, and through it all, the rhythm of the universe will continue, steady, patient, eternal. Beyond the galaxies lies an even deeper mystery. Something unseen drives the universe to expand at an ever-increasing rate. Scientists call it dark energy. Unlike dark matter, which pulls things together, dark energy pushes them apart. It fills the fabric of space itself, influencing how galaxies move and how the universe will evolve in the future. We cannot touch it, and we do not yet understand what it is. It is a silent force that shapes everything, from the largest clusters of galaxies to the smallest particles of light. It reminds us that much of reality lies beyond the limits of our perception. The more we study the cosmos, the more we discover how delicate the balance truly is. Gravity pulls galaxies together, while dark energy drives them apart. Between these two extremes, the universe finds harmony. It grows, but it does not yet tear itself apart. It expands, but it still holds its stars in graceful motion. This balance is the reason we exist, a fragile equilibrium that allows matter to gather, stars to form, and life to arise. Imagine for a moment that you are floating at the edge of the Milky Way. From that vantage point, the galaxy would appear as a luminous whirlpool of stars, its spiral arms glowing in pale blue and gold. You would see rivers of light winding outward, each one containing billions of suns. Beyond that, faint smudges of distant galaxies shimmer in the darkness. Every one of them is a universe of its own, filled with endless worlds, hidden moons, and possibilities yet to be known. Now think of this. All of it began from something smaller than a single atom. From one point of unimaginable density came everything: the stars, the galaxies, the air you breathe. And it continues still. Space is expanding, galaxies are drifting, and the story of creation goes on in silence. Every heartbeat, every breath, every thought is part of that ongoing expansion. You are part of the same process that began 14 billion years ago. You are made of the same light that once filled the first stars. So as you listen to this story of movement and mystery, allow yourself to feel small, but also infinite. Because to be small in the universe is not to be insignificant. It is to be part of something vast, something timeless. You are a note in a cosmic symphony that has played since the dawn of existence. And though your sound may be brief, it is essential to the harmony of it all. If this reflection brings you a moment of peace, take it with you into your rest. Let the thought of galaxies and gravity lull your mind into stillness. The next part of our journey will drift deeper into the dawn of light, when the universe first began to shine. In the beginning, after the first expansion and cooling, the universe fell into darkness. There were no stars, no galaxies, and no light. Only hydrogen, helium, and traces of other simple elements drifted through space like an endless ocean of invisible gas. For hundreds of millions of years, the cosmos existed in this quiet shadow, waiting for the moment when gravity would awaken it again. As time passed, tiny fluctuations in density began to gather matter together. Where gas collected most strongly, clumps formed and grew heavier, slowly collapsing under their own weight. Within these collapsing clouds, pressure and heat increased until the atoms inside began to fuse. At that moment, the first stars were born, brilliant, massive, and short-lived. They ignited the universe's first dawn. The long cosmic night ended, replaced by a glow that spread through space like the first rays of a sunrise. These early stars were unlike the ones we see today. They burned hotter, brighter, and lived for only a few million years. They were composed almost entirely of hydrogen and helium, the purest elements forged in the Big Bang. As they burned, they fused these simple gases into heavier elements: carbon, oxygen, and iron, the building blocks of everything to come. When these massive stars exhausted their fuel, they exploded in spectacular supernovae, scattering those new elements across the cosmos. Each explosion enriched the surrounding gas, preparing it to form new generations of stars and planets. The universe, once empty, became fertile. This period is known as the Cosmic Dawn, the era when light first returned to the universe. It marked the beginning of structure, color, and energy spreading through the void. As the first galaxies began to form, their combined light started to reionize the hydrogen gas that filled space, clearing away the cosmic fog. The universe, which had been opaque to radiation, became transparent for the first time. Light could now travel freely through space, revealing the patterns and structures that had always been there but hidden in darkness. Imagine what that moment must have looked like: a vast expanse that had known only silence, suddenly illuminated by billions of newborn stars. Their light traveled outward in every direction, reflecting off clouds of gas and awakening the universe's first colors. If you could have stood there to witness it, you would have seen the birth of beauty itself, not just physical light, but the first moments when energy became form, when darkness gave way to radiance. The cosmos was no longer still, it was alive. From these first stars, the earliest galaxies took shape. They gathered in clusters, connected by invisible threads of gravity and dark matter. Each galaxy became a city of light, filled with hundreds of billions of stars orbiting one another in silent harmony. Over billions of years, some merged to form larger galaxies, while others drifted quietly in isolation. This was the universe's great architecture, taking form a network of light and matter, stretching farther than imagination. Even now, we can see faint echoes of that time. The light from those first stars still travels through space, reaching us after nearly 14 billion years. It arrives as a soft glow, almost invisible, but measurable with delicate instruments. It carries with it a story: the moment when the universe first learned to shine. Each photon from that ancient light is a message from the dawn of time, whispering that the universe once awoke from its slumber and began to dream in brightness. Without those first stars, nothing we know could exist. Their fusion created the heavy elements that later formed planets, oceans, and life. The calcium in your bones, the oxygen you breathe, the carbon that forms your body, all were born in the hearts of stars that lived and died long before the Sunday. When you look at the night sky, you are seeing your own origins written in starlight. You are the continuation of that first light, the echo of the cosmic dawn. The early universe was not a single explosion of creation, but a continuous unfolding. Even as the first stars died, new ones were born, and the cycle of illumination carried on. That rhythm persists even now, billions of years later. Every sunrise, every flicker of fire, every spark of thought is a small reflection of that original glow. Light has never stopped expanding, it only changes form. As you rest, imagine the universe around you not as empty but as alive with that same quiet brilliance. The light of the first stars still lingers in every corner of space, touching everything that exists, including you. You are a child of that dawn, born from the light that still moves through eternity. If this image fills you with calm wonder, stay with it a little longer. Let the thought of ancient light remind you that even from darkness, something radiant can always emerge. The next part of our journey will follow that light as it travels through space and time, tracing the story of the cosmic background that still glows around us today. Even now, the light from the universe's earliest moments continues to travel through space. It has crossed unimaginable distances and outlasted everything that once produced it. This ancient light is called the cosmic microwave background, a faint glow that fills the entire universe. It is the oldest light we can observe, a silent echo from when the cosmos was still young. Everywhere we look, this radiation surrounds us, coming from every direction equally, like a soft and endless whisper. The cosmic microwave background is not bright or visible to the naked eye. It exists in wavelengths far beyond human sight, detected only with sensitive instruments. Yet, when scientists translate those faint signals into images, they reveal something astonishing. Across the sky, the light appears almost perfectly uniform, the same temperature in every direction, but with tiny variations, mere millionths of a degree. Those minute ripples represent the earliest fingerprints of structure in the universe. They show where matter was slightly denser, where gravity would later pull gas together to form galaxies and clusters. In those subtle patterns, the future of everything was already written. When astronomers mapped this ancient light in detail, they found that it carries clues about the age, shape, and destiny of the cosmos. By studying its faint fluctuations, scientists learned that the universe is about 13.8 billion years old. They discovered that its geometry is remarkably flat, meaning space itself neither curves inward like a sphere nor outward like a saddle. This flatness tells us that the universe has expanded in near-perfect balance since its beginning, guided by forces so finely tuned that even a small deviation would have led to collapse or endless chaos. It is as if creation itself was set upon a narrow edge, and somehow, it remains there still. The light of the cosmic background is not just radiation, it is memory. Each photon has traveled uncountable miles, untouched and unchanged since the universe first became transparent. Before that time, light could not move freely. It was trapped in a dense fog of particles, scattering endlessly. But when space cooled enough for atoms to form, the fog cleared, and the first light began its journey. Those photons have been traveling ever since, crossing billions of years to arrive here, to reach the small planet where you now listen. When you stand beneath the night sky, that ancient light passes through you without notice. It flows gently across your skin, through every atom, through every breath. You are surrounded by it always, wrapped in the afterglow of creation itself. Every moment, billions of those ancient photons reach Earth, a constant reminder of how deeply connected we are to the universe's beginning. If we could see it with our eyes, the sky would never truly be dark. It would glow faintly with the warmth of its own origin. This radiation, invisible and persistent, has become one of the most important discoveries in modern science. When two radio astronomers, Arno Penzias and Robert Wilson, first detected it in 1965, they thought they had found interference. They checked their instruments for static, cleaned out every possible source of noise, even the pigeons nesting in their antenna, yet the faint hum remained. It was only later that they realized what they were hearing was not noise at all, but the remnant echo of the Big Bang itself. That hum was the oldest sound in the universe, still resonating through time. Today, we use satellites like the Cosmic Background Explorer and the Planck Observatory to study this ancient light in extraordinary detail. These missions have revealed a map of the early universe, a snapshot taken when it was only 380,000 years old. In that map, we can see the seeds of all future structure, the places where galaxies, clusters, and superclusters would one day form. It is a cosmic photograph, frozen in time yet endlessly unfolding through us. Imagine the universe as it was then, still glowing from its birth, filled with faint light and potential. That light has dimmed and stretched as the universe expanded, its wavelength elongated into the microwave range. But it has never vanished. It still lingers everywhere, woven into the fabric of reality. You are bathed in it at this very moment, whether you sit beneath city lights or in complete darkness. The warmth you feel from it is barely above absolute zero, yet it connects you directly to the origin of everything. When you think of this ancient glow, remember that it carries the story of all that has ever been. It holds the memory of when matter first formed, when time began to flow, and when the universe took its first breath. It is both a relic and a promise, proof that nothing truly disappears, only changes form. The light that began long ago has never stopped traveling, and in its journey, it has passed through you. You are made of the same energy that once filled the cosmos with brightness. In a sense, the universe still shines within you. So, as you breathe, imagine that soft, ancient glow surrounding you, filling the silence with warmth older than the stars. It is not just history. It is presence, the living trace of creation that hums quietly in the background of existence. Stay with that thought. Let it drift through your mind like the gentle wave it is. Because even now, in the deepest quiet, the universe still glows. From the moment the first light filled the universe, gravity began its patient work, shaping everything that would come after. Every particle, every wisp of gas, every drop of energy was drawn toward every other, slowly weaving the great architecture of the cosmos. Over billions of years, gravity turned chaos into pattern and emptiness into form. It sculpted galaxies, bound stars together, and created the vast cosmic web that stretches across the universe. Yet gravity's reach extends far beyond the visible. It touches light itself, bending and twisting its path as it travels through space. When light passes near a massive object, a star, a galaxy, or a cluster of galaxies, its path curves because of gravity. This effect, known as gravitational lensing, allows us to see how invisible forces bend the very fabric of space-time. A distant galaxy's light can be magnified and distorted by another galaxy lying between it and us. Sometimes the result is a ring of light, other times a set of mirrored images scattered across the sky. Through this natural lens, the universe reveals its hidden structure. Astronomers use it to map dark matter, which cannot be seen directly but reveals itself through the way it bends light. Every distortion is a signature, a clue about the unseen forces shaping creation. On the largest scales, gravity not only sculpts the visible world, but also leaves imprints on the ancient light we still detect today. The cosmic microwave background, that faint relic of the Big Bang, carries tiny patterns caused by the pull of massive structures billions of years later. As light travels through the universe, it passes near galaxies and clusters, whose gravity stretches and warps it ever so slightly. Those small distortions, measured with extraordinary precision, tell us where matter lies and how the universe has grown. By reading those faint marks, scientists can trace the evolution of cosmic structure from its first seeds to the grand formations we see now. It is remarkable to think that gravity, a force so familiar on Earth, also governs the motion of galaxies across billions of light years. It holds the moon in orbit, keeps your feet on the ground, and at the same time binds together the most distant corners of the cosmos. Every object in existence exerts its pull on every other, no matter how faint, no matter how far. When you drop a stone or breathe in the air, the atoms that make up your body respond not only to Earth's gravity, but to the combined influence of everything: the stars, the galaxies, even the dark matter that surrounds them. You are not separate from that web. You are part of its constant movement, connected by an invisible thread that runs through all things. Gravitational lensing has given humanity one of its most powerful tools to study the invisible universe. Through it, astronomers have discovered entire clusters of galaxies that were hidden behind others. They have measured the shape of the cosmic web, revealed the distribution of dark matter, and even observed light from galaxies so distant that it began its journey before Earth existed. Sometimes, the bending of light amplifies distant objects, turning the universe itself into a giant telescope. In that way, gravity becomes both artist and observer, a silent hand painting the sky with curves of light. But gravity's artistry is not limited to light alone. It shapes the flow of time itself. Near massive objects, time slows down. The stronger the gravity, the slower the passage of moments. This strange truth, confirmed by Einstein's theory of general relativity, means that time is not a constant rhythm, ticking everywhere the same. Instead, it bends and stretches with space, forming an inseparable fabric. When you stand on Earth, time moves slightly slower for you than it does for a satellite in orbit. Across galaxies, that difference becomes immense, stretching seconds into centuries. The universe is not ruled by clockwork, but by gravity's slow, elegant pulse. Even the smallest changes caused by gravity can have profound effects. As galaxies move and collide, their combined forces send ripples through space, gravitational waves that travel outward at the speed of light. For billions of years, these waves have carried the echoes of cosmic events across the universe. When two black holes merge or a star collapses, the very fabric of space-time trembles, releasing energy unlike anything else in nature. In 2015, scientists detected these ripples for the first time using instruments sensitive enough to measure distortions smaller than a fraction of a proton. That discovery confirmed what Einstein predicted a century earlier. Space itself is alive, vibrating gently with the memory of cosmic motion. Everything you know, from your heartbeat to the orbit of distant galaxies, moves to the same rhythm. Gravity links every motion and connects every moment, from the fall of rain to the collapse of stars. It is not just a force, it is a language, spoken through the curves of light and the flow of time. To listen to gravity is to hear the heartbeat of the universe. So as you rest, imagine that soundless pulse flowing through you. It holds the stars above, it carries planets around suns, and it moves within every atom that makes up your being. You are part of that same gravity, part of that same dance. In stillness, you are moving with the universe, always falling toward everything, and everything falling gently toward you. Measuring the scale of the universe has always been one of humanity's most profound challenges. Our world once seemed infinite, bounded only by the horizon and the stars above. Yet as we looked deeper, we realized that those points of light were not fixed in a crystal sphere, but scattered across unimaginable distances. To understand the cosmos, scientists needed a way to measure those distances, to build a bridge between Earth and the farthest galaxies. That bridge became known as the cosmic distance ladder. Each step of this ladder represents a different method of measurement, calibrated carefully from the closest stars to the farthest reaches of space. It begins with parallax, the same technique that your eyes use to judge depth. As Earth orbits the Sun, nearby stars appear to shift slightly against the background of more distant ones. By measuring that tiny shift, astronomers can calculate how far away the star is. For the nearest few thousand stars, this simple geometry provides a foundation, the first rung on the ladder of the universe. But beyond that, parallax alone cannot reach far enough. The next step uses something called standard candles, celestial objects whose true brightness is known. If you know how bright something truly is, and you see how dim it appears, you can determine its distance. Certain types of stars, like Cepheid variables, pulsate in a rhythm directly related to their intrinsic brightness. By comparing the pattern of their pulses, astronomers can estimate how far away they are. This discovery, made over a century ago, was what allowed Edwin Hubble to measure the expansion of the universe itself. Those pulsing stars became lighthouses guiding us through cosmic darkness. The next rung of the ladder reaches even farther, using supernovae, colossal stellar explosions that briefly outshine entire galaxies. Type Ia supernovae always reach nearly the same peak brightness before fading, making them ideal for measuring distances across billions of light-years. By observing how bright or faint they appear, astronomers can trace how fast galaxies are moving away. It was through these supernovae that scientists first discovered the acceleration of the universe's expansion, revealing the presence of dark energy. Each flash of light, lasting only weeks, became a clue about the fate of the cosmos. Every rung on the distance ladder must be connected to the one below it, forming a chain of trust that links Earth to the edge of the observable universe. Errors at one step can ripple through the others, so astronomers refine their measurements constantly, comparing multiple techniques to ensure accuracy. From radar echoes of nearby planets to the faint shimmer of galaxies billions of light-years away, every piece of data adds another note to the symphony of cosmic scale. We now know that the observable universe stretches roughly 93 billion light-years across a number so vast that it defies intuition. And yet, this number is only a part of something far greater, for beyond what we can observe may lie an infinite expanse, still hidden from view. The cosmic distance ladder is more than a scientific tool. It is a story of human persistence, curiosity, and imagination. It shows how we, tiny beings on a small blue world, have learned to measure the immeasurable. Each technique, each observation, is a testament to our need to understand where we stand in the universe. The ladder is not made of metal or wood, but of light, logic, and time, an ascent through knowledge rather than space. It is how humanity has learned to climb beyond the limits of sight and into the realm of understanding. Imagine standing at the bottom of that ladder, looking upward into the depths of the cosmos. Each rung above you glows faintly, a star, a galaxy, a flash of supernova light, each one a step toward infinity. As you climb higher in thought, the view expands until the entire universe unfolds before you. From nearby stars to the cosmic horizon, every level of distance connects back to the moment of the Big Bang. The light that reaches you is ancient, but the knowledge it brings is timeless. And yet, even with all these measurements, the vastness of the universe remains humbling. We can describe it with equations and numbers, but we can never truly feel its size. It stretches beyond imagination, beyond what language can express. Still, every calculation brings us closer to awe, the realization that we live inside something grand and continuous, something that keeps revealing itself the more we look. The universe does not need us to measure it, but through measuring, we find meaning. We come to understand that to look outward is also to look inward, because the same laws that guide the galaxies also shape the atoms within us. So when you gaze at the night sky, remember the invisible ladder that connects your eyes to the farthest stars. Each point of light you see is a step in that climb, a journey across time, carried by photons older than the Earth itself. You are standing at the base of eternity, looking up through eons of light. The next part of our journey will explore that horizon, the farthest edge we can see, and the mysteries that lie beyond it. Beyond the reach of our telescopes lies the cosmic horizon, the farthest distance from which light has had time to reach us since the beginning of everything. It marks the limit of what we can observe, not because there is an edge to the universe, but because light from beyond that point has not yet arrived. We are surrounded by this horizon in all directions, a glowing boundary that defines our visible universe. It is both a wall of time and a reminder of how young our understanding still is. The cosmic horizon is not fixed. It expands as the universe ages. Every second, more light travels toward us from distant galaxies, slowly revealing new regions of space that were once hidden. In this way, the observable universe is constantly growing, not because the cosmos itself is changing shape, but because time allows us to see more of it. Each new photon that reaches our instruments extends the boundary of human knowledge just a little farther. We are explorers of light, charting a sea that continues to unfold as we drift through it. Imagine the universe as a vast ocean, and the cosmic horizon as the edge of the map, the place where old cartographers once wrote, "Here be dragons." Beyond that limit, our theories and imagination take over. We cannot see what lies there, but we know the expansion continues endlessly. There may be countless more galaxies, each with their own clusters, stars, and worlds. Perhaps entire regions of space follow different physical laws, born from other bursts of creation like our own Big Bang. In those unobservable realms, time may flow differently, gravity may behave in strange ways, and light itself may never find its way to us. The horizon reminds us of the delicate balance between what we know and what remains unknowable. It humbles us, reminding us that even with our greatest technologies, we can only glimpse a fraction of reality. Our instruments reach deep into the past, nearly 14 billion years, yet beyond that lies a silence we cannot pierce. This silence is not empty. It is the vast potential of what is still hidden. Every moment, new light continues its journey toward us, carrying stories from places we will never touch but can still imagine. The expansion of the universe means that some galaxies are moving away so quickly that their light will never reach us. No matter how long we wait, their signals will fade beyond detection, carried away faster than light by the stretching of space itself. In time, even the nearest galaxies outside our local group will drift so far that they disappear from view entirely. Billions of years from now, an observer in the Milky Way might see only the faint glow of nearby stars, and nothing beyond a universe that seems empty and still. But we live at a special moment, when the cosmos is still bright and full of visible connection. We are witnesses to a brief window in which the universe reveals its grandeur before darkness returns to hide it once more. The cosmic horizon also carries a quiet philosophical truth. Just as there are limits to what we can see in space, there are horizons within our own understanding. We cannot perceive everything, no matter how deeply we look. Every discovery opens a door, but beyond it waits another layer of mystery. In this way, the universe mirrors our consciousness, expanding, exploring, and yet always reaching toward something just beyond comprehension. It teaches us patience, reminding us that wonder thrives not only in answers but in the questions that remain. Even though we cannot cross the cosmic horizon, we can imagine what lies beyond it through mathematics and theory. Physicists use simulations to model how space might behave outside our observable bubble. Some theories suggest that the universe could be infinite, repeating endlessly in patterns too vast to comprehend. Others propose that we live within a single pocket of a much larger multiverse, one of many bubbles expanding through a higher dimensional sea. If that is true, then everything we know, every atom, every star, every dream, is just one ripple in an eternal ocean of creation. Though we may never see those other realms, their possibility gives us a sense of scale and humility that words cannot capture. The horizon defines the boundary of what we can know, but it does not define the limits of imagination. Our curiosity is itself a form of light, traveling outward into the unknown. Each time we ask what lies beyond, we expand the reach of thought, if not sight. Perhaps that is the purpose of our awareness, to mirror the universe's own expansion, to seek, to question, and to grow. In doing so, we participate in the same unfolding that began at the dawn of time. We are, in a sense, the universe trying to see beyond its own horizon. So tonight, as you think of the stars, picture that invisible boundary surrounding you. You are at the center of your own observable universe, wrapped in the glow of ancient light. Beyond that glow, space stretches endlessly into mystery, and though your eyes cannot see it, your mind can reach it, tracing the horizon of wonder itself. Stay here a moment longer, and let that thought become stillness, because sometimes, to understand infinity, all you must do is be quiet enough to feel it. Everywhere we look, the universe is filled with light, but it is also shaped by vast regions of emptiness. Between the filaments of galaxies and clusters, there are immense stretches of nearly perfect void. These cosmic voids are not truly empty. They contain a thin mist of gas, a scattering of dark matter, and the faint whisper of radiation. Yet compared to the crowded regions of the cosmic web, they are oceans of silence. Each void can span tens or even hundreds of millions of light years across, dwarfing the galaxies that border them. They are the dark spaces between the threads of creation, shaping the universe through absence rather than presence. At first, astronomers thought these voids were simply gaps, places where matter had not yet gathered. But over time, they discovered that voids play a fundamental role in the structure of the cosmos. Just as hills and valleys define the shape of a landscape, the distribution of galaxies and voids defines the topography of the universe. Gravity pulls matter together, creating dense filaments and clusters, while the spaces between expand, deepening the cosmic valleys. This process continues even now, as matter flows slowly out of the voids and into the web, leaving behind regions of astonishing emptiness. Inside a void, galaxies drift farther apart than anywhere else. The pull of gravity is weaker there, and expansion dominates. If you could stand at the center of one, the night sky would appear strangely bare, only a handful of galaxies scattered across the blackness. You would see the universe's grand structure from its quietest room, surrounded by silence so deep that even light seems reluctant to pass through. And yet, those empty regions tell us more than we might expect. By studying how galaxies move around voids, scientists learn about the behavior of dark energy and the overall shape of space-time itself. Voids act like natural laboratories where the universe reveals how it expands, bends, and evolves. The existence of such vast emptiness reminds us that balance defines all things. Where there is density, there must also be space. Where there is light, there must also be darkness for it to shine. The universe is not just a collection of stars, but a relationship between what is there and what is not. The cosmic web is a conversation between gravity and nothingness, a dance of presence and absence played across unimaginable scales. Even the most brilliant galaxy owes its form to the silent expanses that surround it. The structure of the universe is remarkably consistent on the largest scales. If you could look from far enough away, you would see patterns repeating threads, knots, and voids, forming a network that stretches endlessly. This vast repetition is known as the large-scale structure, and it looks surprisingly similar, no matter where you focus. From one region of the cosmos to another, the same web-like geometry emerges. It is as if the universe follows a simple, elegant design, repeating itself in variations of light and shadow. This self-similarity, called cosmic homogeneity, is one of the great mysteries of cosmology. Why does everything appear so evenly distributed when the forces that shaped it are so complex? The answer lies partly in the early universe, when tiny fluctuations in density spread outward during cosmic inflation. Those minute ripples became the framework of everything, the seeds of both galaxies and the voids between them. Over billions of years, gravity amplified those small differences, pulling matter together and stretching the gaps wider. The result is the delicate cosmic lace we see today, where filaments form highways of galaxies and voids create the space between their intersections. Even now, that structure continues to evolve, as galaxies drift and dark energy reshapes the expansion of everything. The universe, though vast and ancient, is not frozen. It is alive, always moving toward balance. In recent years, astronomers have used powerful surveys to map the cosmic web in extraordinary detail. Projects like the Sloan Digital Sky Survey have charted millions of galaxies, revealing a three-dimensional view of the universe's structure. When those data are visualized, they show an intricate mesh-bright clusters connected by thin threads, surrounded by enormous voids. It looks almost biological, like the neural network of a cosmic mind. Some scientists even note that the structure of the universe resembles the connections within the human brain, though separated by unimaginable scales. It is as if the pattern of creation repeats itself, from the smallest neurons to the largest galaxies. The same laws of connection and flow seem to echo across every level of existence. When you think of these vast empty spaces, do not imagine them as nothingness. They are the silence that allows the universe to sing. They are the canvas upon which light paints its story. In their stillness lies the contrast that makes beauty possible for a star to shine. There must be darkness around it. Even in your own life, meaning often comes not from constant motion but from the quiet spaces between moments. In the same way, the cosmos breathes between galaxies, expanding and resting in a rhythm older than time. If you close your eyes and picture it, you might see not emptiness, but harmony. A balance of light and space, energy and stillness, creation and pause. The universe is not crowded chaos, but an unfolding of perfect proportions, shaped by both what exists and what does not. And somewhere within that grand equilibrium, you find yourself a brief awareness surrounded by infinity. Stay here for a moment and let that image settle in your thoughts. Between every heartbeat, there is silence, just as between every galaxy there is space. It is within those silent spaces that the universe speaks most clearly. In the next part of our journey, we will follow that silence deeper into the origins of galaxies, where the cosmic web gathers light and begins to glow. From the stillness of the cosmic voids, we return to the glowing bridges of light that thread between them the great filaments of the universe. These are the highways of creation, the luminous paths where galaxies are born and carried through space. Stretching for hundreds of millions of light years, they form the skeleton of the cosmos. Clusters of galaxies gather at their intersections like shining cities, while rivers of dark matter and gas flow silently along their invisible routes. It is within these filaments that gravity and energy come together, weaving the intricate architecture of everything that exists. Each filament is made mostly of dark matter, a ghostly substance we cannot see, yet whose gravity binds the visible universe together. Through these unseen threads, ordinary matter follows gas clouds drifting like mist, cooling and collapsing until they ignite into stars. The process is slow, deliberate, and ancient, but unending. In the emptiness between the threads, light struggles to exist. But along the filaments, creation continues, powered by the same forces that first stirred the universe to life. The galaxies within these filaments are not isolated islands. They are part of a network connected across unimaginable distances. Their movements are guided by gravity's deep currents, drawn along invisible lines that determine their paths. As they orbit and merge, their stars and dust mix, enriching the cosmos with new elements. Over time, these interactions create the patterns we see: spirals, clusters, and vast arcs of glowing matter that trace the universe's evolution. Though it appears chaotic, the motion of galaxies follows a subtle order, a balance that maintains the integrity of the cosmic web. If you could step back far enough to see it all at once, the universe would resemble a vast, living structure, an organism made of light and gravity. Each filament would shimmer faintly, glowing where galaxies congregate like nodes in a neural network. The similarity to the connections within the human brain is striking. Both systems use patterns of connection to transfer information and energy. In one, electrical impulses carry thoughts and memories. In the other, light and gravity carry the history of the cosmos. Perhaps consciousness itself is not an accident of biology, but an echo of the universe's deeper design, a reflection of the same harmony that shaped the stars. Between the filaments, vast voids remain, expanding like slow breaths between the beats of cosmic creation. Matter flows from those empty regions into the luminous threads, guided by the pull of dark matter. This constant exchange gives the universe its structure, a dynamic equilibrium between contraction and expansion, light and darkness. Without the voids, the filaments would collapse. Without the filaments, the voids would have no form. Together, they compose a cosmic heartbeat, an eternal rhythm that keeps the universe alive. Scientists map these colossal structures using the faint glow of distant galaxies. Each dot of light on their charts marks a galaxy, each cluster a node in the web. When the data are compiled, a delicate mesh emerges so vast that even light takes hundreds of millions of years to cross a single strand. Supercomputers simulate how this web grows, showing matter gathering along filaments and pooling at intersections. It is a slow choreography that has continued since the beginning, guided by gravity, dark matter, and the expansion of space. Every movement within it, from the swirl of a galaxy to the drift of a single particle, follows the same cosmic rhythm. Within these filaments, new galaxies form in the densest regions of gas. Gravity pulls hydrogen and helium together, and as they compress, stars begin to ignite. These young galaxies shine brightly, their light traveling for billions of years to reach us. Each spark marks a new generation of creation, continuing the same process that began with the first stars. Even now, deep in the far reaches of the cosmos, galaxies are still forming, fed by the endless flow of matter along the web. It is as if the universe itself is still growing, its structure refining, its energy redistributing, its balance unfolding without end. In the densest intersections of the web, gravity creates colossal galaxy clusters. Each cluster contains hundreds or even thousands of galaxies, surrounded by hot gas that glows in X-rays. These are the densest nodes of the cosmic network, where galaxies interact most strongly. They merge, collide, and sometimes trigger new waves of star formation. Between them, magnetic fields and cosmic rays weave unseen patterns, further linking the galaxies in complex harmony. It is a reminder that the universe, for all its vastness, is not empty chaos, but a system of relationships, a web of connection holding all things in tension and grace. If you were to drift among these filaments, you would see light and darkness intertwined, galaxies glowing like lanterns along invisible bridges, threads of gas illuminated by ancient radiation, and the quiet shadows between them where silence reigns. Everywhere, gravity hums softly, a vibration that holds the structure together. And through that vibration, everything moves: stars, orbiting stars, galaxies circling clusters, clusters forming superclusters. The universe is a single organism breathing through its own expansion, a living geometry made of time and light. When you look up at the night sky, you see only the tiniest fraction of this vast web. Each star you notice belongs to a galaxy that sits within one of these filaments, connected to billions of others across space. You are part of that network too, a collection of atoms once scattered through ancient stars, now gathered here to observe the whole. To know that is to feel both small and infinite. You are a pattern within the pattern, a spark in the same cosmic lattice that holds galaxies in place. Take a moment to breathe and imagine yourself suspended within this grand structure. Around you stretches the quiet glow of creation, flowing endlessly between light and darkness. This is the cosmic web, the universe's most delicate masterpiece, the bridge between existence and emptiness. And as you drift within it, remember that every thread of it also runs through you. In the vast tapestry of the cosmos, certain regions shine with unmatched brilliance. These are the galaxy clusters, immense gatherings of hundreds, sometimes thousands, of galaxies bound together by gravity. They form the densest knots of the cosmic web, places where the threads of dark matter, gas, and light converge. Each cluster is a city of galaxies where cosmic evolution unfolds on a grand scale. They move, collide, and merge over billions of years, sculpting the universe into its present form. Within a typical galaxy cluster, stars are only a small fraction of the total mass. Most of it exists as dark matter, the invisible glue that holds the cluster together. The rest is hot gas, heated to millions of degrees by the immense gravitational forces at play. This gas emits X-rays, allowing astronomers to see the cluster's glowing halo even where visible light fades. What appears to us as stillness is in fact motion, galaxies orbiting each other at thousands of kilometers per second, their paths woven into an intricate dance of attraction and inertia. Some clusters are so massive that they bend light from objects behind them, acting as natural gravitational lenses. Through these cosmic magnifying glasses, astronomers can peer even deeper into space, observing galaxies from the earliest epochs of the universe. In a single image, the present and the distant past coexist nearby galaxies, glowing calmly in the foreground, while ancient light arcs faintly behind them. It is as though the cluster itself is a portal through which time and space converge. Among the largest known clusters is the Coma cluster, over 300 million light-years away. It contains more than 1,000 galaxies, all moving within a shared gravitational field. When astronomers first studied its motion, they noticed something strange. The visible matter could not account for the gravity required to keep it together. This was one of the first clues that dark matter must exist, a silent force outweighing the visible stars by a wide margin. Since then, countless other clusters have confirmed this same mysterious pattern. The visible universe is only the surface of a far deeper structure, one defined by unseen mass and invisible energy. Clusters do not exist in isolation. They connect to one another through the filaments of the cosmic web, forming superclusters that stretch for hundreds of millions of light-years. Our own Milky Way belongs to one such structure, the Laniakea supercluster, whose name means immense heaven. It contains over 100,000 galaxies, all flowing together through a region of space shaped by gravity's subtle pull. Each cluster within Laniakea moves as part of a greater current, like eddies in a cosmic ocean. And somewhere along one of its quiet streams, our galaxy drifts a single light in an immense river of stars. If you could see the Laniakea supercluster from above, it would look like a vast whirlpool of light. Galaxies and clusters spiral inward toward regions of higher density, moving as though drawn by an unseen hand. Scientists have identified one such region, the Great Attractor, a gravitational anomaly pulling entire clusters toward it. We do not yet understand what lies there, for much of it is hidden behind the dust of our own Milky Way. But its influence is undeniable. Even as the universe expands, local gravity gathers matter into these grand formations, keeping creation bound within its own rhythm. The interplay between gravity and expansion creates a balance that shapes everything. On smaller scales, gravity dominates, binding stars into galaxies and galaxies into clusters. But on larger scales, dark energy pushes space apart, stretching the distances between superclusters. The universe is a dialogue between these two forces, one pulling together, the other driving apart. It is in this dialogue that all structure arises. Every star you see, every galaxy that glows, exists because of this cosmic tension. Without it, there would be only stillness, a universe without form or motion. Galaxy clusters are also the birthplace of cosmic phenomena that ripple across millions of light years. When clusters merge, they generate shock waves that heat, gas, and accelerate particles to near light speeds. Magnetic fields twist and stretch, creating jets of radiation that travel vast distances. These events are rare, but their effects endure for billions of years, leaving behind radio halos and arcs of charged particles. Each one is a trace of the universe's ongoing evolution, a reminder that even in stillness, energy moves. Imagine floating between the galaxies of a massive cluster. Around you, countless suns burn silently, their light merging into a diffuse glow that fills the sky. You would see other galaxies drifting like islands, some spiraling gracefully, others colliding in slow motion. Far beyond them, filaments of faint light extend into darkness, connecting one cluster to another. Everywhere you look, gravity hums not in sound, but in motion, shaping every orbit, every stream, every curve of light. To observe a cluster is to witness both unity and impermanence. Over immense timescales, these structures will change. Some galaxies will merge, others will be flung outward by gravitational tides. Stars will burn out, and new ones will ignite in the embers of old collisions. And yet, the cluster will endure, bound by the same force that first brought it together. It will remain a monument to the persistence of gravity, a shining testament to the order within cosmic chaos. As you rest, think of this balance of countless galaxies moving in quiet precision, their light traveling through the same universe that holds you now. The same gravity that binds them holds you too. You are not separate from those clusters, you are made of their remnants. The iron in your blood, the calcium in your bones, the oxygen in your breath, all were forged in the fires of ancient galaxies like these. To look at a cluster is to look at your own origin, written not in words, but in light. At the heart of almost every galaxy lies a secret, a colossal presence that shapes everything around it. These are supermassive black holes, cosmic engines millions or even billions of times the mass of the Sunday. They are not empty voids, but regions of space where gravity has become so strong that nothing, not even light, can escape. Around them, space twists and time slows, bending reality into forms that defy imagination. Yet, from this darkness, some of the brightest phenomena in the universe are born. When matter falls toward a black hole, it does not simply disappear. It forms a swirling disk called an accretion disk, a storm of gas and dust spinning at nearly the speed of light. Friction within the disk heats the material to millions of degrees, causing it to glow with intense radiation. The result is a paradox, an object that shines brighter than entire galaxies, powered by the most complete darkness known. These radiant beacons are called quasars, and they are among the most distant and luminous objects we can see. Quasars are the voices of the early universe, their light traveling billions of years to reach us. They serve as cosmic lighthouses, revealing the landscape of deep space and the conditions that existed when galaxies were still young. Each quasar marks a supermassive black hole consuming matter at an extraordinary rate, transforming gravitational energy into light. Some shine with the brightness of 1 trillion suns, visible across the universe, even as their host galaxies remain hidden. Through their glow, astronomers trace the growth of black holes and the evolution of the cosmos itself. These black holes are not merely destructive, they are also creators. Their immense gravity influences the birth of stars and the flow of gas within galaxies. Jets of high-energy particles erupt from their poles, launched by magnetic forces near the event horizon. These jets travel for millions of light-years, shaping entire regions of space, heating intergalactic gas, and regulating star formation. In this way, black holes act as both sculptors and guardians of galaxies, engines of balance that maintain the universe's rhythm. At the center of our own Milky Way lies such a giant. Astronomers call it Sagittarius A*, a supermassive black hole about 4 million times the mass of our Sunday. For most of its life, it has remained quiet, surrounded by stars, orbiting it in graceful loops. But from time to time, it awakens, drawing in clouds of gas and glowing faintly in X-rays as it feeds. If you could watch from a safe distance, you would see space itself curve around it, light bending into rings before vanishing past the horizon. No sound, no explosion, just silent gravity, pulling the universe inward with infinite patience. Despite their terrifying nature, black holes may hold the key to understanding the fabric of reality. At their centers lies a mystery called the singularity, a point where our laws of physics break down. Here, density and gravity become infinite, and the known equations of space-time no longer apply. Scientists believe that understanding singularities could unlock a unified theory, connecting general relativity with quantum mechanics. It is as if black holes are gateways, not merely to destruction, but to deeper truth. Some theories even suggest that new universes could emerge within them, each one budding off from the collapse of another. Black holes also warp the passage of time in ways that defy everyday experience. Near their event horizons, time slows dramatically relative to the outside world. A few minutes near one could equal years elsewhere. This means that, in theory, someone orbiting close to a black hole could look outward and see the universe's future unfold before returning home. Though we cannot yet test this idea directly, the concept reminds us how inseparable time and gravity truly are. In the presence of immense mass, even time bends to gravity's will. Recent breakthroughs have allowed us to see these enigmatic giants for the first time. In 2019, the Event Horizon Telescope captured the first direct image of a black hole, a glowing ring surrounding a dark center. It was not an artist's interpretation, but a real glimpse of the edge of the unseeable. That image, from the galaxy M87, showed light bending around a shadow billions of times larger than our world. It was a photograph of gravity itself, a moment that connected imagination to reality. And though it revealed much, it also deepened the mystery. What lies beyond that dark horizon remains hidden, perhaps forever. In every direction, black holes shape the universe quietly. They consume, they create, and they define. Without them, galaxies might never have formed, stars might never have clustered, and space might not have achieved its structure. They are the anchors of the cosmos, giving weight and order to everything we see. Even when they seem to erase matter, they preserve its essence in another form: energy, radiation, motion. They are reminders that even in apparent endings, there is continuation. So as you imagine these great celestial hearts pulsing in silence at the centers of galaxies, remember that the same laws governing them shape you as well. You are not separate from that gravity or that light. The same fabric of space-time that curves around black holes also weaves through every atom of your being. You are part of that structure, a fragment of the same continuum that holds both stars and shadows. And in the stillness of thought, you may feel it, the quiet pull that connects all things, the gravity that binds existence together. From the darkness of black holes and the radiance of quasars, the story of the universe flows back to something softer, the quiet birthplaces of stars. Inside galaxies, vast clouds of gas and dust drift through space like invisible tides. They are cold, dense, and patient, waiting for gravity to weave them together. Over time, small regions within these clouds begin to collapse under their own weight, heating slowly as the particles draw closer. From that gentle compression, light is born again. A new star ignites, sending the first glimmers of warmth into the surrounding dark. These clouds are called nebulae, the stellar nurseries of the universe. They are immense, stretching for hundreds of light years across, their colors glowing in delicate shades of red, blue, and gold. Each one is a cradle of creation, where thousands of stars can form within a single cluster. Some nebulae are illuminated from within by the newborn stars they shelter. Others remain hidden, their secrets veiled by dust. When we look at images from telescopes like Hubble or the James Webb, we see those cradles glowing softly, sculpted by radiation and time. It is in these clouds that the cycle of life begins again, where the ashes of ancient stars gather to form the next generation of suns and worlds. The process is slow and delicate. At first, atoms of hydrogen collide and fuse into helium, releasing vast amounts of energy. This nuclear fusion pushes outward, balancing the inward pull of gravity. For millions or billions of years, that balance holds, allowing a star to shine steadily. The size of a star determines its fate. Small stars burn slowly, glowing gently for trillions of years, while massive ones live fast and die young, ending in cataclysmic explosions. Every point of light in the night sky is a fusion of balance and tension creation held between gravity and fire. Around these young stars, disks of gas and dust begin to form. Within those swirling disks, particles collide, stick together, and grow into planetesimals, the seeds of future planets. Over time, some gather enough mass to form rocky worlds, others swell into gas giants, and some remain as icy remnants drifting at the edges of their systems. The story of every planet begins here, in these thin disks of matter circling new suns. The same process once shaped our own solar system, giving birth to Earth, to the Moon, and to the vast diversity of worlds that orbit beyond. To watch such a system forming is to glimpse creation in motion, chaos sculpting order, dust transforming into landscapes and oceans. The interplay between star birth and star death maintains the rhythm of the cosmos. When massive stars end their lives as supernovae, they scatter heavy elements, carbon, oxygen, iron into space. Those elements mix with interstellar gas, seeding future stars and planets with the materials for life. Every breath you take contains atoms forged in the cores of long-dead suns. The cycle continues endlessly. Stars form, shine, explode, and give rise to new generations. It is the universe breathing, a continuous exchange of energy and matter. Even now, somewhere in a distant nebula, new stars are igniting, continuing a process older than time itself. Some of the most beautiful regions in space are shaped by these forces. The Orion Nebula, visible even to the naked eye, is one of the brightest and most active star-forming regions in our galaxy. Inside it, massive clouds swirl with turbulence as young stars carve cavities in the gas with their radiation. Elsewhere, in the Eagle Nebula, towering columns of dust known as the Pillars of Creation stand like ancient monuments, hiding hundreds of new stars being born within their shadows. These places remind us that creation is not always quiet. It is powerful, dynamic, and often violent, yet it always gives way to beauty. The death of a star can be just as spectacular as its birth. When a massive star collapses, it creates shock waves that compress nearby clouds, triggering new rounds of star formation. Thus, endings become beginnings. Every supernova is both a farewell and a spark of renewal. Even black holes, born from stellar death, help shape their surroundings by releasing powerful jets that stimulate growth elsewhere. The universe, in its infinite complexity, wastes nothing. Every fragment of destruction becomes a seed for new creation. To understand this cycle is to understand life itself. We, too, are built from this rhythm: creation, transformation, renewal. The atoms that form your body once belonged to ancient stars, scattered through space before finding each other here, within you. When you breathe, when you think, when you dream, the universe experiences itself through you. The light that once glowed in a distant nebula now burns quietly in your cells. You are made of the same material that gives birth to galaxies. In this way, existence is continuous. Stars become matter, matter becomes life, and life returns to the stars. So tonight, as you look at the sky, know that you are seeing not only the past, but your own origin. Those clouds of gas and light are part of the story that made you possible. The same forces that formed suns and planets now flow through your veins. You are both observer and participant, both creation and creator. The stars you gaze upon are your ancestors, and someday, the atoms within you will return to them, completing the cycle once again. As the universe matured, it began to weave a grand story of transformation, a story written in light, matter, and time. From the birth of the first stars came all the heavier elements that would one day form worlds, oceans, and life. The universe, once composed only of hydrogen and helium, grew richer and more complex with every generation of stars. Each cycle of birth and death deepened the cosmic chemistry, creating new possibilities for creation. The cosmos was no longer just expanding, it was evolving. Over billions of years, galaxies gathered into immense structures, and stars organized themselves into vast patterns. In the process, invisible forces continued to shape the grand design. Magnetic fields stretched across galaxies like unseen threads, guiding the movement of gas and dust. Though these fields are weak compared to gravity, their influence is far-reaching. They steer charged particles, sculpt nebulae, and even control how new stars form. Through them, the universe gains structure and symmetry, an invisible order hidden beneath the chaos of light. In galaxies like our own, magnetic fields create intricate patterns that trace spiral arms. Charged particles moving within these fields emit faint radio waves, revealing the invisible contours of cosmic magnetism. Every galaxy becomes both a generator and a canvas, producing magnetic loops that interact with stars, supernovae, and black holes. The result is a delicate balance, an interplay between motion, field, and matter that gives each galaxy its personality. From the vast whirlpools of spiral galaxies to the elliptical glows of older ones, magnetism weaves a quiet rhythm into everything we see. Within these galaxies, supermassive black holes continue to act as engines of transformation. Their immense gravity pulls in surrounding gas, creating jets of charged particles that stream outward at nearly the speed of light. These jets, stretching for millions of light years, interact with the intergalactic medium, heating gas and altering how stars form. By regulating the flow of matter, black holes prevent galaxies from growing uncontrollably, keeping balance between expansion and collapse. In their silence, they play the role of cosmic architects, ensuring that creation does not consume itself. The same gravity that devours also preserves, turning destruction into harmony. These magnetic fields and gravitational flows combine to shape one of the most astonishing structures in existence: galaxy clusters. Within them, hundreds of galaxies drift together through a sea of hot plasma and dark matter. The space between is not empty. It hums with invisible energy, echoing with radio waves and X-rays. Jets from central black holes pierce through this environment, stirring the gas and creating cavities that glow faintly in high-energy light. Through these interactions, clusters evolve not as static systems, but as living networks of energy exchange. Every movement, every burst, every ripple adds another note to the cosmic symphony. Sometimes, when clusters collide, the scale of these events defies imagination. Two giants meet, each containing trillions of stars, and merge over billions of years. During the collision, gas clouds compress, magnetic fields twist, and shock waves ripple through space. These encounters can trigger bursts of new star formation or ignite dormant black holes, turning darkness into radiant light. The energy released by such mergers is beyond comprehension, yet, from our small world, we can detect its echoes across the universe. Each collision leaves an imprint, a signature that reveals how galaxies and clusters have grown over time. To the human eye, these processes unfold too slowly to witness, but telescopes capture them across cosmic time, stitching together the universe's memory. Images from instruments like the Chandra X-ray Observatory and the James Webb Space Telescope reveal this dynamic interplay in vivid detail. They show galaxies breathing, magnetic lines curving through clusters, and jets painting the darkness with streaks of energy. Every picture is a frozen moment of motion, a pause in the continuous unfolding of cosmic history. Through them, we see not chaos, but continuity, a pattern of balance that endures even through the most violent transformations. The universe is not a static masterpiece, but a living organism, always changing yet always preserving its essence. Every galaxy, every star, and every field contributes to a larger harmony. Even the emptiest spaces resonate with the memory of creation, vibrating faintly with the energy left behind by ancient events. This hum of existence connects all things, from the glow of the most distant quasar to the pulse of your own heart. It is a reminder that the same forces that shape galaxies also move within you. The magnetic fields that thread the stars are the same that guide the particles inside your body. The rhythm of energy and matter that sustains the cosmos sustains you as well. When you look at the night sky, you are not looking outward, but inward into the pattern that you are part of. The galaxies above are not strangers. They are your reflection in a grander mirror. You are made of their remnants, born from their dust, powered by the same light that first ignited among them. Every cell, every atom, every spark of thought carries the story of the cosmos in miniature. You are proof that the universe is self-aware, that it can look upon itself and wonder, and in that awareness lies the greatest beauty. Creation not only exists, it understands. So as you drift deeper into this journey, let your mind rest on that thought. You are the continuation of the stars, the echo of energy still finding its form. The same physics that governs galaxies governs your heartbeat. In a universe so vast, consciousness is its quiet reflection, the smallest yet most profound act of light. And as the cosmos continues to expand, your awareness expands with it, both part of the same endless unfolding. As we look deeper into the universe, we begin to see not only light, but the subtle imprints that gravity and motion have left upon it. The cosmos carries its own memory, etched into the faint radiation that surrounds us. This ancient light, the cosmic microwave background, still bears the fingerprints of the universe's earliest fluctuations, small ripples of density that became the galaxies and clusters we see today. Yet even this light is not untouched. On its long journey across billions of years, it has been bent, stretched, and shaped by the mass of everything it passed. The result is a map of gravity itself, a silent record of how matter is distributed across all of space. This effect, known as gravitational lensing, allows scientists to trace both the visible and invisible structure of the universe. Light from distant galaxies is gently curved by the gravitational pull of the matter it encounters. Sometimes, the bending is strong enough to create multiple images of the same galaxy, mirrored and distorted across the sky. Other times, it is subtle, a faint stretching of background light that reveals where dark matter hides. By studying these distortions, astronomers can create detailed maps of the cosmic web, showing how matter clumps and spreads across the heavens. Through light, we see the shadow of the unseen. Gravitational lensing does more than show us where dark matter lies. It also tells us how the universe has evolved. As light passes through clusters and filaments, the amount of bending depends on how much mass they contain and how far they have grown. This makes lensing one of the most powerful tools in modern cosmology. It allows scientists to test theories about dark energy, measure the universe's rate of expansion, and confirm the predictions of general relativity on cosmic scales. Every warped image, every curve of light, is a data point in the ongoing story of creation. Through them, we witness how gravity sculpts not only space, but also time. The interplay of light and gravity reaches its most dramatic form near black holes. Here, the curvature of space-time becomes so extreme that light can orbit the black hole several times before escaping. When viewed from afar, this creates luminous rings, the so-called Einstein rings that frame the darkness within. These rings are not illusions, but real pathways of light twisted around mass. They remind us that what we see is not always straightforward. Even the simplest beam of light carries the complexity of the entire universe's geometry. The light we receive from the earliest moments of time has traveled through this ever-changing landscape, bending and stretching along the way. What we see is therefore not a direct view of the past, but a distorted reflection shaped by everything in between. The universe, in this sense, acts like a great lens, constantly reshaping its own image. Through it, we see not just what once was, but how reality itself transforms as it expands. It is a humbling reminder that observation is never separate from the cosmic story. We are part of the process, woven into the same web of light and matter. Einstein's theory of general relativity first predicted this bending of light more than a century ago. When it was confirmed by observation during a solar eclipse in 1919, the world saw, for the first time, that space itself could bend. The sun's gravity shifted the position of nearby stars ever so slightly, just as Einstein had predicted. That discovery reshaped our understanding of the cosmos. Space was no longer an empty stage upon which events took place. It was an active participant in creation, flexible, dynamic, alive. Since then, every observation of gravitational lensing, every measurement of curvature, has confirmed that the universe is not a static void, but a living fabric. In recent decades, astronomers have used this phenomenon to peer farther back in time than ever before. Massive galaxy clusters, acting as natural lenses, magnify the light of distant galaxies that would otherwise be invisible. Through these cosmic windows, we can now see galaxies that formed just a few 100 million years after the Big Bang. Their faint light, amplified by gravity itself, offers glimpses of the universe's childhood, the moment when the first stars and structures took shape. Each new observation adds another frame to the cosmic film, revealing how the universe grew from simplicity into complexity. But gravitational lensing is not limited to light. It also affects time. When light passes through a strong gravitational field, its path lengthens and its clock slows. This means that some light from distant events arrives slightly later than expected. In this way, lensing lets us watch cosmic phenomena unfold with a kind of natural delay, as though the universe itself were replaying its own history. The delay may be minutes, years, or even centuries, depending on the distance and mass involved. In the vast scale of the cosmos, even light, the fastest thing in existence, must yield to gravity's will. Every photon that reaches your eyes carries a story of motion, curvature, and transformation. It has crossed galaxies, bent around clusters, and stretched with the expansion of space. It has interacted with dust, plasma, and invisible fields. By the time it arrives, that single particle of light has lived a journey billions of years long. And yet, in that instant, it meets you. The act of observing completes the circle. You too are part of the universe seeing itself, your awareness another reflection of light returning home. So, when you look at the stars, remember that their light is not a straight line, but a conversation between gravity and distance, between time and existence. The night sky is a lens through which the universe remembers its own shape. And as you gaze into that curved infinity, you are both observer and participant, both mirror and light. Everything you see, and everything that sees you, is bound together by the same invisible geometry, the same eternal curve that holds the cosmos in its gentle embrace. The light that fills the universe tells us not only what is there, but also how everything moves and changes. For astronomers, the color of light is a language, one that reveals distance, motion, and time itself. When light travels through expanding space, its wavelength stretches, shifting toward the red end of the spectrum. This phenomenon, known as redshift, is one of the most powerful tools for understanding the history of the cosmos. Every beam of starlight carries within it a record of how much the universe has grown since it began its journey. To measure this expansion, scientists turn to the Hubble constant, the value that defines how fast galaxies are moving away from one another. But even this constant is not truly constant. Over time, as the balance between dark energy and gravity changes, the rate of expansion evolves. Some galaxies drift gently, while others race away faster than we can imagine, carried by the stretching of space itself. By observing redshift across billions of light years, astronomers can trace this rhythm, the acceleration and deceleration that describe the universe's heartbeat. Through light, the cosmos reveals the tempo of its own expansion. Every redshifted galaxy is like a note in a cosmic symphony. Together, they form a pattern that tells the story of the universe's growth, from its fiery birth to its still unfolding present. Light from distant galaxies left them when the cosmos was young, traveling through expanding space. Its wavelength stretched by the journey, That stretching does not come from movement through space, but from space itself expanding. It is as though the universe is an ocean, and light is the ripple spreading across it, its wave growing longer with every passing second. The concept of redshift connects directly to the idea of cosmic time. When we look at a galaxy billions of light years away, we are not seeing it as it is now, but as it was when its light began traveling. Each color corresponds to an age. The farther away the object, the redder its light, and the older its story. In this way, telescopes become time machines, allowing us to witness the universe's history written across the spectrum of light. Every observation is a look backward through the corridors of time, a journey into the universe's memory. As the universe expands, even the background light left from the Big Bang is stretched. Once brilliant and blinding, it has cooled and dimmed into the faint microwave radiation we now detect the cosmic microwave background. This light, now just a few degrees above absolute zero, fills every part of space, carrying the imprint of all the expansion that has occurred since the beginning. In its cold glow, we can see the accumulation of time itself, an ancient echo that has followed the universe through every stage of its evolution. The color of that glow, invisible to human eyes but clear to our instruments, is a direct measure of how far the cosmos has come since its birth. Yet even as we measure these vast scales, the universe remains elusive. Two different methods of calculating the Hubble constant produce slightly different results. One uses nearby stars and galaxies. The other relies on the ancient light of the cosmic microwave background. The discrepancy between them, known as the Hubble tension, has puzzled scientists for years. It might point to something profound, a gap in our understanding of dark energy, or even new physics that reshapes the foundations of cosmology. The answer remains uncertain, but within that uncertainty lies opportunity, the promise that the universe still holds mysteries waiting to be uncovered. What we do know is that the expansion continues. Galaxies drift farther apart, and the light between them stretches thinner. Over billions of years, this expansion will carry most galaxies beyond visibility, their light redshifted until it fades completely. The night sky, so full of stars today, will grow darker and quieter in the distant future. Only the galaxies bound together by gravity, like our local group, will remain visible small islands of light adrift in an ever-growing sea of darkness. It is a gentle but inevitable truth. Even as the universe expands, light continues to travel, forever chasing horizons that retreat faster than it can reach them. Redshift is more than a measurement. It is a reminder that everything is in motion. Even now, the atoms in your body are part of that same expansion. Space itself stretches through and around you, carrying every particle in subtle rhythm with the cosmos. You may feel still, but you are moving with the flow of creation, an inseparable part of the expanding whole. In this way, redshift is not only a property of galaxies but of existence itself, a reflection of time unfolding in every direction. To understand this is to see the unity of all things. Light, space, time, and matter are not separate, they are expressions of the same fabric. When light stretches, it tells us that the universe is growing. When galaxies drift away, they remind us that change is not loss, but transformation. And as the cosmos expands into the future, it carries us with it not as observers standing outside, but as participants in the grand motion of reality. So as you rest, imagine yourself floating gently within that flow. The stars recede, the light stretches, and time unfolds like a wave that carries you forward. You are part of that same journey, one that began long before you were born and will continue long after you are gone. The expansion of the universe is not distant. It is happening within you, right now, in every atom, every thought, every breath. To exist is to move with the cosmos, to drift through eternity in quiet harmony with the infinite. Every galaxy, every star, every grain of dust is part of a story that began with the simplest elements, hydrogen and helium. From these two building blocks, all the complexity of the universe has emerged. Through the hearts of stars, the cosmos has slowly learned to create itself. As stars burn, they fuse lighter elements into heavier ones, producing the carbon, oxygen, nitrogen, and iron that make up worlds and life. This is the process of stellar evolution, the universe's quiet alchemy. The earliest stars, known as population 3 stars, were massive and short-lived. They burned with unimaginable brightness, consuming their fuel quickly before exploding as supernovae. Those explosions scattered the first heavy elements across space, enriching the cosmic gas from which later generations of stars would form. Without them, there would be no planets, no oceans, no breath, no life. Every atom of your body except hydrogen was forged in the core of a star that lived and died long before the Earth existed. We are, in the most literal sense, made of stardust. As the universe aged, new generations of stars formed from this enriched material. Each generation lived longer, burned steadier, and produced even more complex elements. Ironically, the heavier the elements became, the easier it was for matter to cool and condense into planets and moons. This gradual enrichment transformed the cosmos from a sea of pure hydrogen into a landscape of diversity, where stars, planets, and eventually living beings could take shape. It was the beginning of cosmic maturity, when the universe evolved from simplicity into creation capable of reflection. Within galaxies, the cycle of life and death continues endlessly. Massive stars live fast and die spectacularly, while smaller ones linger quietly for billions of years. When the largest stars collapse, their explosions seed nearby regions with new material, triggering fresh waves of star formation. The remnants of those explosions, neutron stars and black holes, remain as the skeletons of ancient giants, reminders of what once burned bright. Each generation of stars builds upon the ashes of the last, and in this continuity lies the memory of the cosmos itself. Our own sun is a third-generation star. It was born from gas and dust that had already been processed by earlier stellar lives. Around it, a swirling disk of material coalesced to form the planets of our solar system. From those same particles came everything we know: the rocks beneath our feet, the air we breathe, and the molecules that form thought and emotion. In a single handful of Earth's soil, you hold atoms that were once part of stars scattered across different corners of the galaxy. They traveled for billions of years, waiting for this moment to become part of a living being capable of wonder. The life cycle of stars is not only a story of transformation but also of balance. A star's brilliance depends on the constant struggle between gravity pulling inward and fusion pushing outward. When those forces balance, a star shines steadily, maintaining stability for millions or billions of years. But when the balance breaks, when fuel runs out or gravity overwhelms pressure, the star's life ends dramatically. In its death, it releases everything it has made, returning to the universe what it once borrowed. That return is not loss, but renewal. Through death, the universe ensures that creation continues. Even now, new stars are forming in the spiral arms of our galaxy. Massive clouds of gas collapse, ignite, and begin to shine, while others fade into white dwarfs or drift as cold remnants. If we could speed up time, the Milky Way would look like a living organism pulsing with birth, light, decay, and renewal. Galaxies are not static islands of stars. They are ecosystems, always evolving. Each pulse of light, each faint flare in a nebula, is another heartbeat in the life of the cosmos. The evolution of stars also drives the chemistry of everything we know. Inside their cores, Extreme temperatures fuse atomic nuclei together, overcoming forces that would otherwise keep them apart. Hydrogen becomes helium, helium becomes carbon, carbon becomes oxygen and iron. When a star dies, those elements scatter, merging into new clouds and becoming part of other stars. It is a cosmic recycling system that has operated flawlessly for more than 13 billion years. And within that process, something miraculous occurs. Complexity arises from simplicity, consciousness from chaos, life from starlight. When you look up at the night sky, you are seeing the history of your own existence. Those points of light are not distant strangers, they are the ancestors of your atoms. Each one is part of the same process that formed you, a continuous chain of transformation stretching across space and time. To gaze at the stars is to remember who you are. A brief flicker of awareness, born from the oldest fires in the universe. You are the universe contemplating itself, a spark of memory carried on the breath of ancient light. So when you breathe, remember that the oxygen in your lungs once flowed through the heart of a red giant. The calcium in your bones was forged in the core of a dying sun. The carbon in your body came from the ashes of long-vanished stars. In every heartbeat, the cosmos continues its story through you. You are not apart from the stars. You are their continuation. And just as they burn and fade, you too are part of that endless rhythm: creation, transformation, and return. Good night, and see you in the next video.